Okay, students, this is your well-rounded math teacher, Mr. Picard, and you are starting Unit 2, Notes Video 1 today, Relations, Functions, and Linear Equations. Learning target is kind of expanded here a little bit. You can identify parts of relations, including domain and range, find x and y intercepts, and what makes a relation a function. We'll jump right into this. Table shows the average maximum lifetimes for some animals, represents this data as ordered pairs, or it says represent this data as ordered pairs with average lifetime being x and maximum lifetime being y. The reason x is average lifetime, this is what we call our independent variable. Your independent variable is always your x variable. And we're going to call the maximum lifetime y because that depends on our independent variable. The average lifespan of a cat is 12 years. It's always going to be 12 years. The maximum lifetime is 28 years, and that depends on average lifetime. So this is x is your independent variable, y is your dependent variable. Anyway, coming up with some ordered pairs here. You can see if x is 12 and 28 is your y, that's going to be 12, 28. 15 and 30 is the next ordered pair, x and y. 8 and 20. 12 and 20 for the dogs. And 20 and 50 for the horses. Horse lived 50 years. That's pretty cool. Okay. This is what we call a relation right here. Set of ordered pairs is a relation. Okay, some things about a set of ordered pairs or your relation is the domain. The domain is a set of all first coordinates or your x coordinates. So our domain up here, relation is a set of ordered pairs, but more specifically the domain D is all the x coordinates. So our domain for this would be 12, 15, 8, 12 again, I guess, and 20. Usually when you're talking domain and range, you do not have to repeat a number twice, so you could just have 1 12 in there. Our range, you would guess, is a set of all the second coordinates or the y coordinates. I'll put our range up here. And notice I'm using braces because we're writing it in set notation. We got 28, 30, 20, another 20, and 50. And once again, I didn't have to list the 20 twice. I just did anyway. Either way, it's fine. So domain and range. X coordinates is your domain. Y coordinates are your range. Now a function is a special, let's move this over a little bit, is a special relation in which each element in the domain pairs with exactly one element in the range. In other words, it's one-to-one. A function basically is this, and it only works for domain, not range. X value, basically your domain values, does not repeat. X value does not repeat. So if I was looking at this first relation, and I was looking at my domain, I would notice that there's a 12 here and a 12 here. So this relation would not be a function. Okay, this relation would not be a function because the x value does repeat. We got a mapping here. Mapping is just this. It takes all your ordered pairs and splits them up into one domain and one range in these ovals here, I guess they would be called. Now you can see that there was one ordered pair of 12 and 28. Another ordered pair of 15 and 30. And then one of 8 and 20. It looks very similar to our other numbers up here, but in this particular mapping, we just have 3 x values and none of them repeat, so this would be a function. Okay, another way to look at functions as a string of ordered pairs, like this, where it's a continuous graph. Okay, and they're going to ask you, is this a function, yes or no? Well, does it pass the vertical line test? And the vertical line test is simply this. If you can take a straight vertical line and pass that through your graph and it only hits one point at any particular time, it is a function. If it hits more than 1 point, that means there's 2 x values that are the same, then it would not be a function. So this one, this first graph, is a function. How about this graph? No. Because these 2 x values right here and here are exactly the same. So this is not a function. It doesn't pass the vertical line test. Not a function in that case. Okay. Using your graphic calculator, you can check and see if things are functions also. You could plug this in and see if it's a function. The key is this. It has to be solved for y. If it's not solved for y, you really can't plug it into your graphing calculator. So I'm going to pull up our graphing calculator here. And I'm going to show you how to plug this in. First of all, I'm going to hit clear. And you're going to go y equals, this button up here on the upper left hand, it says stat plot underneath it. Just hit y equals and it gives you all these things. y1, y2, y3, these are different functions that you could plug in for your calculator. Anyway, here y equals 3x squared minus 5. So I'm going to type in 3. I need an x variable. Now I'm not using the blue x's here. I'm using this one right over here. It's next to the green alpha key. It's x, t, alpha, and n. We're going to hit that right there. It's squared, so I'm going to hit the caret key and hit 2. I'm just going to hit an arrow to the right over there to get down again, and then minus 5. And enter. There's our graph. One thing before we actually go to graph this, notice that plot 1, plot 2, and plot 3 on top of my graphing calculator are not highlighted. If they were highlighted like this, it's not going to let you graph. So if any of them are highlighted, just arrow up to it, hit enter to unhighlight it, and then go back down. When we graph, I want you to go to zoom, this middle button on the top here, hit zoom. And then right here at number 6 it says Z standard, that's zoom standard, that gives you a standard size screen. So I'm going to hit 6 and that'll graph it for us. Well, is it a function, yes or no? Vertical line test. If I take a vertical line, no matter where I draw that on the graphing calculator, I'm only going to hit 1 point. So I would say that yes, this passes the vertical line test because you're only going to hit 1 point at a time. So, yeah, that would be a function. Okay. So it says state the domain and range of each function, or I'm sorry, each relation. This is a relation right here. And then determine if it's a function or not. Well, my domain, using my braces, -4, -3, 0, and 1. Nothing repeats there for my domain, so this is a function. Doesn't matter what the range is, because you only have to worry about the domain repeating. My range is 0, 1, -2, and 2. And there we go. That is a function because the x values don't repeat. And here we go, number 2. Here's a bunch of ordered pairs. They're all scattered around. They're actually graphed here. So we're going to state our domain. We're just going to pick each and every x value. Here we got -4, -1, and 0. And here I have 2 and 3. No, none of the x values repeat. So this is a function once again. Putting my y values in there. I got y values. Well, I have 2 3s. You only need to list one of them. And they can repeat. Your y values can repeat. I have -2, -3, and -4 also. I could list the 3 twice if you want to. Doesn't really matter, but you don't have to. So, once again, this is a function. The y values did repeat, but that doesn't matter. It's the x values that you worry about. So, function notation. If a relation is a function, you can replace the y with the f of x. For example, if I had y equals 2x minus 3, if I graph this, I'm going to get a line, and it is a function. So you can take and replace the y and give it the title of f of x equals 2x minus 3. Basically, y and f of x are the exact same thing. So when I'm looking at this given, f of x equals x squared plus 2, that's the same thing as y equals x squared plus 2. Okay? We're going to talk about, we already talked a little bit about independent variables. Your independent variable is the x variable or the domain, and your dependent variable is the y variable representing the range. Usually one of the variables depends on the outcome of the other one first, like time. Time is a given. That's usually your independent variable. And what other variable you're working with would probably be your dependent variable depending on time. Anyway, we're going to evaluate some functions here. This says given f of x equals x squared plus 2, find f of -3. They basically want you to just plug in -3 wherever you see x in the expression part. This is the expression part of my function. So if I want to find f of -3, that means I plug -3 in for this x right up here. I'm squaring that x and I'm adding 2. Now it's just order of operations. I don't worry about this anymore. This is just my title of my function, and it's telling me what my input of the function is. This is what I want to evaluate over here. -3 squared, which is -3 times -3, or 9, plus 2 is 11. So f of -3, our output is 11. Okay. Let's evaluate a few more functions here. Here we're going to be given give us a little room to work. Here we're going to be given g of x. So the title of our function is g now. G of x equals 3x minus x squared. It says evaluate the following. First one, we're just plugging a number in again. If I want to find g of 2, that means I plug 2 in wherever I see an x and then evaluate it. So 3 times 2 minus 2 squared, and then it's just order of operations again. There are no variables left here, so parentheses, there's only one term in each parenthesis here. Exponent, so I'm going to do this exponent right here. 2 squared is 4. So it's 3 times 2. Now, this subtraction or negative is not squared, just the 2 is squared, so it's minus 4. Multiplication and division, that would be 6 minus 4, or 2. So g of 2 is actually equal to 2. Okay. Let's look at the next one here. Okay, this is an interesting one, and this is where some people get a little bit confused because they see multiplication here. Well, what you're going to do is you're going to evaluate g of 3 first, find out whatever that is, and evaluate g of -1, find out whatever that is, and then multiply the two answers together. So first of all, finding g of 3. That's going to be 3 times 3, plugging the 3 in for x, minus 3 squared. So this is 3 times 3. Squaring this 3 first, I get minus 9. I end up with 9 minus 9, or 0. So g of 3 equals 0. So keep that in mind. We're going to use that in a minute. G of negative 1 equals 3 times negative 1 minus negative 1 squared. And 3 times negative 1 minus negative 1 times negative 1 is positive 1. This is negative 3 minus 1. Negative 3 minus 1 is negative 4. So G of negative 1 is equal to negative 4. So I have my two answers. Now what I do with them is multiply. I take G of 3 first, which is 0, and I multiply it by G of 1 here, negative 1, which is negative 4. And my answer in this case, final answer, is 0. So evaluate these two, find them separately, and then multiply your two answers together. That's how you multiply two functions that you're trying to evaluate. Okay, what do we got here? Next one. Oh, already did that one. Okay. G of 3x. Now we're not just plugging a number into our function. Now we're plugging this whole thing, a little variable term, 3x. It looks complicated, but wherever I see an x right here, I'm going to input 3x. So 3x becomes 3 times x, which is 3x, because that's what we're inputting here, minus the 3x squared. Well, I would get rid of your exponents first. 3x squared is actually 3x times 3x. This is what we're trying to evaluate right here. That's 9x squared. So it's 3 times 3x minus 9x squared. Finally, just multiplying here, I get 9x minus 9x squared. They're not like terms, so I can't combine them together. This would be my final answer right here. If there's a variable inside that you're trying to plug in for your x term right here, you're probably going to have that variable left over when you're done. So a little bit with evaluating functions. Okay, linear equations. A lot going on with linear equations. Most of it is review for you guys. Linear equations have no other operations than addition, subtraction, and multiplication of a variable by a constant. When I think of linear equations, I think of this, slope-intercept form. And that is y equals mx plus b. Now this is just one way to write linear equations, slope-intercept form. We're going to talk about standard form down here in a minute. This is another way to write linear equations. The main thing when you're looking at linear equations is this. The m, if it's solved for y, this is solved for y. I'll just write it right here. Your m is your slope, your rise over run. And your b, whatever that is your y-intercept. And the reason slope-intercept form is nice is you can just graph your y-intercept and then kick in your slope using rise over run. It's very easy to graph your linear equations. But the thing you got to remember, what differentiates a function or any function from a linear function is this. If it's a linear function or linear equation, x and y are to the first power. If you have x squared or y squared, it's automatically not a linear equation, so they both have to be the first power. Another thing you can look at is this. Here's slope-intercept form, 1/3 x plus, we'll say 4, which would be very easy to graph. In fact, I'm going to graph it right now. I see that x is to the first power, y is to the first power. This is a linear equation. My y-intercept is 4, so I'm going to go up 1, 2, 3, 4. And my slope is 1/3. That's the same as rise over run. So I'd go up 1 from this point and over 1, 2, 3. And there's another point. Oops. So it's very easy to graph what's in slope-intercept form. And you see a fraction here, and that's fine if it's all numbers. But when you're working with linear equations, you can't have something like y equals 7 over x. Oh boy. I'll say 1 over x plus 5. Try this again. Y equals 1 over x plus 5. You would think this is a linear equation, but you're dividing by a variable here. You cannot divide by variables if it's going to be a linear equation. So two things that if it asks you if it's a linear equation or not are x and y both to the first power, and I'm not dividing by a variable. Okay, so this is just stating this is a linear function. F of x is basically the same as y. This is m is still going to be your slope, b is still going to be your y-intercept. And standard form, the only difference between standard form and slope-intercept form, standard form isn't solved for y. Your x term and your y term are on the left-hand side of your equation, and c is just your constant, and that is on the right-hand side of the equation. Constant is the same thing as the number. And we're going to look at how to graph these equations when they're in both forms. But moving over to x and y intercepts. Your x-intercept is where your line crosses the x-axis. So my x-intercept here is the ordered pair 4, 0. If they're asking for just the x-intercept, it's usually just the number 4. It's your x-coordinate in your ordered pair. Same thing with your y-intercept. Now this ordered pair is the 0, 4. But the y value, or your y-intercept in this case, once again would just be 4. 1, 2, 3, 1, 2, 3, 4, right there. 0, 4. Okay. First question here. Number 4. Is this a linear equation? This is no different than y equals 3x. So whether it's a linear equation or a linear function, in this case it would be yes. Why? X and y are to the first power. Okay. Next one. Number 5 here. Y equals 7 over x. They're both to the first power, but this is still no. Can't divide by. By a variable, or in this case, by x. Last one here, number 6. Y equals x to the 4th minus 5. Is this a linear equation, yes or no? And you should be saying no. Why not? Well, I would say x is to the 4th power. Not hour, power. Okay. Now, if you look at this graph, it should not be a line. One way, if you're not sure, you can always just get your graphing calculator out and graph it and see what it looks like. So we're going to go back to y equals, hit the y equals button. Let's just clear that out and type in this equation right here. Y equals x to the 4th minus 5. Once again, when you're plugging things into your graphing calculator to graph them, it's got to be solved for y. Hit your little x variable right there next to the green alpha key, caret, because it has an exponent. To get out of there, go over to the right and say minus 5. Hit enter. We've already zoomed it in. You should hit zoom standard. So let's just go to the graph and see what it looks like. Once again, you can see this is not a line. Not a line in this case. Okay. Moving along here. It says find x-intercept, y-intercept, and then graph. Okay. When you ever want to find your x-intercept, where something crosses, I don't know, we'll say it crosses the x-axis right here. My y value here is 0. So if you ever want to find your x-intercept, you plug in 0 for y. So I'm going to take this equation right here, 3x minus 4, and plug 0 in there. And the reason I'm plugging 0 in is I want to find my x-intercept. Plus 12 equals 0. So it's 3x minus 0 plus 12 equals 0. This just gives me 12. And now I'm just going to subtract 12 from both sides and get 3x equals negative 12. Finally, dividing both sides by 3, I get my x-intercept is negative 4. X-intercept is negative 4. For the y-intercept and graphing it, I do it a little bit differently. I would take the original equation and just solve it for y. If you can solve it for y, you're going to put it in slope-intercept form. It's easy to find everything you need then. So 3x minus 4y plus 12 equals 0. If I was going to solve this for y, the first thing I would do is probably subtract 12 from both sides and get 3x minus 4y equals negative 12. Solving for y, I want that x term on the other side, so I'm going to subtract 3x from both sides. And don't forget that this is a negative 4y right here. You always put your x term first, negative 3x minus 12. It is not solved for y yet. The last thing we have to do is divide both sides, or each and every term, by negative 4. That's the same as dividing both sides by negative 4. So my final answer, the negative 4's cancel out, y equals, negative 3 divided by negative 4, that's a positive, and it's just going to be a fraction, 3/4, and you can put the x to the side. 3/4 x. Negative 12 divided by negative 4 is positive 3. So it's in slope-intercept form. What does that mean? I know my slope. My slope is 3/4. And my y-intercept, which we want to find, is this 3 right here. So y-intercept is 3. So I'm going to graph that now. 1, 2, 3. There's my y-intercept. My slope is 3/4. So that from this point, I go up 1, 2, 3. I'm off the graph here a little bit, but over 1, 2, 3, 4. Okay. Or you could do the opposite. Instead of 3/4, do negative 3 over negative 4. So going up 3 and over to the right 4, go down 3, 1, 2, 3, and back 1, 2, 3, 4. Either way, you should wind up with your linear equation. Okay? Okay. Find x-intercept. If I want to find x-intercept, that's when I plug in 0 for y. So 0 for the y equals 3x minus 9. Adding 9 to both sides, I'm going to get 9 equals 3x. Dividing both sides by 3, my x-intercept is 3. My y-intercept and then graph, well, it's already in slope-intercept form. So I know this. My slope is 3, and my y-intercept is negative 9. Okay, my graph kind of goes off the board here a little bit when I try and do that y-intercept to negative 9. Negative 1, 2, 3, 4, 5, 6, 7, 8, 9, right about there. Your slope is 3. M is what we use for slope. That's the same as 3 over 1. So up 1, 2, 3 over 1. Up 1, 2, 3 over 1. You can do this as many times as you want with your slope. up 1, 2, 3, over 1. There's my line, and you can see it crosses at the x-intercept of 3. Y-intercept we decided was -9, and we graphed it. And that is it. Have fun with your worksheet. See you tomorrow.